broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody, and welcome to our another edition of our AMS webinar series. And today's topic is basic three-axis machining. And my name is Joan, and for those of you who don't know me, I am the product manager here at MecSoft. I'll be joined today by Don LaCourse, our support manager, who's going to be actually running through this slide and also showing you the demo. Today's webinar is going to be very hands-on. And it's going to be, we'll also try to keep it interactive. And so next slide, please, Don. So use your chat window for questions, put in your questions during the webinar, and I will be in the background. Pankaj will be also in the background watching the questions, and we'll get to answer them. And if you need to stop Don, if you have any questions that anything that's showing is not clear, you can always stop us. And then we'll also reserve, if time permits, we'll have some time at the end of the webinar for questions and answers. And as usual, a recording of this webinar will be made available. We'll clean it up and give us a day or two to get it ready. It will be on a YouTube channel, and we'll send the link out to all the registered people. Okay, so today's topic, as I mentioned before, is basic three-axis machinings. And we're going to take one or two parts depending on how much time we have. And Don's actually going to go through and show a complete programming of these parts. And these would be, we're just going to be showing some basic three-axis machining, how we can use our product, we'll be focusing on RhinoCAM mostly. And the agenda will start with the part setup. And then we'll go tools and tool libraries. We'll talk about that a little bit. And then he's going to jump into the actual machining, and he's going to go through all the different strategies, including roughing, horizontal roughing or Z-level roughing, Z-level and parallel finishing, radial and spiral finishing. And then finally, he's going to be working with actually looking at and viewing the toolpath motions and talking about different colors and things of that nature. And of course, cut material simulation, and finally post-processing. So without any further delay, Don, you want to take over?
Yeah. Hello, everyone. Glad you could make it this morning for our webinar. In this webinar, we're going to look at two different machining jobs. Both of them are molds. One is a cavity block, cavity insert block. For a mold, and that's what you see on the screen right here. So if you look in the top right picture up here, and also the cross section down below, we just pointed out the types of areas that we're going to be required to machine in this job. So we basically obviously have the cavity itself, which has a contoured shape. A standard cross-section shape that's revolved. And we also have a number of machinable areas such as bosses. We got some pockets. And if you look at the cross-section, that gives you a good idea of what we're going to have to contend with in this and machine programming this part. And then on the right side, you see the green surface. We're calling that a masking surface. You can call it whatever you want, a reference surface or a guide surface or whatever you want to call it. Basically, in the process of reviewing your model and what your approach is going to be to machining this, decided that we didn't want the tool to go into these pocket areas at the top, for finishing. And we don't want the tool to roll over these edges. We want to make those edges nice and sharp. So we add we cut a cross section of the part, revolve it around to create this masking surface here, where you see there's no interruptions other than the bosses sticking out. There's no interruptions in that surface.
And the reason we call that a masking surface is because we want to basically mask some of the features underneath the surface or protect the features from being machined. So we're basically going to be going through stages of machining, and that's the
Mhm.
main reason we're calling that the masking surface.
Yes, if you're familiar with our products, if a surface is visible and you're running a 3-axis operation, it will enter into the calculation of the tool path. So if you don't want something to be machined, you want to mask it or turn it off. Some people just have different layers that they have on and off depending on whether they're, uh, which operation they're working on. Okay, so let's go to the next slide. Here, this slide, it just goes over how we're going to approach programming this part. If you look at the machining job here on the left, we're going to start out with a couple of roughing operations. And you see the note on this is with mask on. So we're going to cut a section and rotate that surface around to create our masking surface. I'll show you how to do that. So we'll have the masking surface on for both of the roughing and a horizontal finishing operation. And then we'll also do a spiral and a radial finishing operations. And then we're going to wrap it up with the profiling around the perimeter. We're going to pocket out the pockets, and actually the areas on top of these bosses, I've decided to treat that as a pocket, which turned out pretty well, rather than a face. And then we also included you see, and we got what we call a mop set. We got 2 mop sets, one at the top which says standard and one at the bottom which says pro. So we're going to be going through the standard operations and the standard configuration to program this. We're going to look at the pro. We have one operation that if you're running the pro, you can use that operation, but we're just going to look at it. It's already programmed. And here's the tools down below that we're going to be using: flat end mills, ball mills, etc., in a quarter radius mill. Because that's a good point. Because when I show you the bottle, there's some fillet radiuses in these areas. Like this first slip, there's a radius in the corner that we don't want to machine out. Okay, so we have a corner radius mill that we're going to use. We're finishing those areas, and there's fillets, in this area around here as well. Okay, so let's go ahead and look at the next project. You may have seen this part before. Basically, it's a thermoform mold. Basically, it's a tooling board with a half section of the part machined on it. And the purpose of this mold is to create packaging material for this product. So it'll be vacuum formed plastic pulled down on top of this mold to create a cavity. And the reason that I selected this particular part is that you'll notice there's no fillet around the bottom edge. Okay. For vacuum or thermoform molds, you don't want to have a sharp edge. You want to have a fillet around there for the plastic to flow easily around. But the reason I picked this is that you don't have to model that fillet. We're going to do it or show you how it's done in the machining process rather than in the design process. And for this part, again, the machining job over here on the left, we got a horizontal roughing, 2 parallel finishings and a horizontal finishing to finish the boss portion of the hair dryer. It's a hair dryer mold. And we got some profiling, and then we have the pro. We have a pencil trace for the pro. But I'm going to show you how a good way to pencil trace without using the pro. For this part, it worked out pretty well, and I'll show you how to do that. And then the tools down here at the bottom. Okay, so let's go into the part, and we're going to fully program the first part from scratch. Okay, so here's our part. You'll see that it's a square block, and it's got a cavity cut into it. Some people may ask, why is there no runners or gates on this? Basically, most of the cases, if you're designing the part or designing the mold, you're not the one that's going to be actually cutting the runners, and that's a highly specialized process that a dedicated engineer will determine the mold flow and the characteristics of the plastic, etc. Determine where the runners are going to be, how large they are, how big the gate is, etc., etc. So a good mold shop will prefer that you don't put any runners and gates and let them do it themselves. So in any 3-axis project, with any project actually, 2-axis, 3-axis, or 4 or 5, is to evaluate the part and what kind of geometry you have to work with, and just get in your mind how you're going to approach the programming of this part. So obviously we just got a cavity block, and then we got a straight cavity cut out, from the top down. So we're going to start on the program tab. For those of you who are very new to the product, you can run the mill module from up here, selecting mill, which will display the machining browser on the left. And in the top portion, we have the machining browser, which is actually called, the top portion is called the machining browser, and the bottom portion is called the machining objects browser. So we got 2 tabs at the top, program and simulate. We're going to do all of our programming here on the program tab. We're going to work our way from left to right, and then we'll use the simulate tab to run any simulations, and we'll use the machining objects browser down here to create or show you some tools. I already have the tools created, but I'll show you how you do that to create the tools, and I'll show you how to save a tool library and load one. Okay, so we're going to start from the programs tab, upper left, and in 3-axis for the machine definition, it's always set to 3-axis, whether you're doing 2-axis or 3-axis. So that's set to 3, and there's really nothing else that you really need to do here unless you're going to do some specialized things such as tool change points, or you've got a very restrictive work envelope. You can set your min-max areas of the machine. So we got that defined. The post itself, this is the same for any operation, 2, 3, 4, or 5. Select your post processor. We have a legacy post selection or programmable post selection. In most cases, you'll be using the legacy post, and you can select the post that you're going to use here. And I'll just select the Haas, if I can find it. Okay, we'll pick OK there. So we got our post defined. Now, under setup, by default, there is one setup that comes with the product when you open any file or new file. Setup 1 will be displayed, and you will also notice that it's also coincides with the world origin of Rhino or VisualCAD CAM. So you don't really have to do anything related to the setup if you're in the standing configuration and then the part's already oriented the way you're going to machine it with the Z up. Your cavity is pointing upward and Z positive. So that's the way it needs to be in order to machine it. So we don't have to worry about setup. Let's move over to stock definition. We got a number of different options for stock. We're just going to do a box, since this block is a box itself. So we're just going to do a box stock. And we're going to assume that the block is finished. In other words, the square blank is machined out to the correct dimensions. The top is flat and machined. We don't have to machine these areas here. We're just going to cut the cavity portion. So we're going to select copy model bounding box, which will measure the length, width, and height of the part itself, the maximum dimensions, and it'll display them here. So it's 20 by 20 by 4 inches high. So we're going to pick OK, and we'll turn our stock on. The artifacts here, you'll see that it's just fighting for display space, since the stock is the exact same dimensions of the part itself. Okay, for alignment, we don't really need to alignment since our stock is the exact size of our part. But if you had like a larger stock, You know, if you wanted to align it with the part itself, you could use the align options here. You can move the stock around in relation to the part itself if needed. And then also there's another option here, set world CS. If your part comes in, if you're importing a part and it comes in way over here somewhere in space, you can use the set world CS to actually move it to the world origin automatically for you. Okay, so we got the machine setup section, we did the stock section. So now we're ready to actually start programming the part. The first thing we want to think about is the work zero. Where on this blank are you going to zero your machine out at? In most cases, it'll be the bottom left corner of your stock, but it can be anywhere on the stock or the part. If you're doing secondary machining operations or another side, you may have a pre-cuts, you know, part of your stock is already cut, so you may want to zero out on the part somewhere. But we're going to zero out at the top left quadrant of the stock itself. So we're going to pick the work zero, and you'll see that you can pick a point to set the program zero, or you can set it to the stock box or set it to the part box, or pick a point. You can pick a point. So we're going to just set it to the stock box. We're going to do it the highest Z, which is the highest point on the stock. And then we're going to put it in the southwest corner. Okay. So I already have one created, so I'm just going to cancel out of this. So it places your work zero in the position that you requested. Now you'll see that I already have a mop set here defined. This is for the Pro configuration. We're just going to leave those for now. We can talk about that after we get it the part programmed. So let's start out and look at some of the tools we have created. We have a lot of tools here listed. Basically, I'll go over this in brief. The first icon here is on the left. If you want to create a new tool, the tool dialog, create select tool dialog will display. Enter your name. Tools are saved by name. So every tool has to have a different unique name. So if you have the same name, it's going to overwrite your tool of the same name. So obviously you want to have different names, descriptive names for each of your tools, dimensions, set the dimensions for each tool, and these are different for each of the tool types up here. You can define your holder, and also over here you can set the properties of the tool material, the cut material color. You can set that if you want to set it here. Number of flutes, the tool number, etc., etc., and then feeds and speeds. You can set those specific for this tool, or you can override these values when you actually do an operation if you want to. So that's how you basically, the process of creating a tool, set your dimensions, pick the save as new tool, it'll load it over here, and you just exit out, or you can select one and edit the dimensions or whatever you need to edit, and then you can save it, override it. So we're going to exit out of that since we already have tools created. So we're going to go right into, and again, if you have any questions, put it in the questions panel. We'll see if we can't get to them during the course of the webinar. Excuse me. So we're going to do some roughing operations to start with. So we're going to go to a 3-axis. We're going to go horizontal roughing. And by default, if you don't select anything for 3-axis roughing, the program already knows where the stock is. It already knows where the part is. So it'll figure out where to cut automatically. So you don't have to select anything. However, it's good to keep a containment area so that you don't end up cutting small areas and areas that you don't really need to be cutting. So we're going to go ahead and select this perimeter curve right here. okay, for the containment area. So we're only going to rough inside that area. So for a tool, we're going to go down here and select, let's see, what do we got here? A 7.5 inch, 3/4 inch flat end mill with the 0 corner radius, meaning it's a sharp, flat end mill. Feeds and speeds. If you have feeds and speeds set for the tool, you can pick the load from tool and it'll populate this dialog with the feeds and speeds that you have defined for the tool, or you can override these values and enter a different value and they will be saved with this specific operation itself. Okay, so we're not going to really set any different feeds and speeds. Those are all specific to your machine, your knowledge of your tools, et cetera, et cetera. So we're not going to dictate what to use. So for the clearance, it comes up with an automatic clearance distance. We're going to leave it set to automatic. For the clearance plane, it'll figure out a safe height. And then for the cut transfer methods, we're going to leave it set to clearance plane, where the tool will retract to this plane and then move to another location if it needs to. And the clearance plane is displayed in red here on the part. Okay, so let's go to the cut parameters for roughing. Now we're going to, by default, every operation, every parameter has a default value when you first install the product. So it makes it really easy for you to generate a quick operation. If you just want to select a containment, pick a tool, and generate, it'll come up with a tool path. Well, we're going to look at each parameter and see what we need to change, if we need to change anything. So the in tolerance and out tolerance, the way the tolerance is calculated in 3-axis is different than it is in 2-axis. In 2-axis, the tolerance only applies in the X and the Y sidewalls, say a pocket, for example. In 3-axis, the tolerance is calculated across the surface contour of the surface. So which means you have the possibility of the tool to being outside of the stock or inside of the stock or the part, and you can set those tolerances, the inside tolerance and the outside tolerance individually. So by default, they're set to 10 thousandths. We'll leave that set for both the in tolerance and the out tolerance. And the stock allowance is the amount of material that's going to remain. The tool, any edge of the tool, in this case, the flat end mill, the corner, will be 25 thousandths away from any part surface. So down here, you've got 2 tabs, cavity pocket regions and core facing regions. If you think about the way your geometry is constructed, we have cavity pockets, obviously, because we have one large cavity. So the core facing will come in to play because inside the cavity, you have these bosses, which are considered cores. So I want to actually save this for a moment because I wanted to show you how to create that masking surface before I forget. So we want the masking surface on when we do the roughing and the finishing. So let's go ahead into a quad view so we can see the part in all axes. So what we want to do is we want to cut a section of the part through an area that has no features. So we're going to want to cut it straight through this area right here, which has the exact cross section of this cavity. So how we're going to do that, we're going to start by just creating a line. Okay, and we want the line to start at the center. So we're going to go down to the object snaps and make sure the center object snap is turned on. And we're just going to pick somewhere in one of these diameters in order to grab that center. So there's our center point. Now we want to drag that line anywhere through the part. I'm doing it right over here, so it cuts right through this area right here. Okay, and what I'm going to do now to generate that section, I'm actually going to calculate a section based on the intersection of a surface and the solid model. So I want to create a surface from this line. So we're going to go up to surfacing. We're going to do extrude curve, straight, So we're going to select this line or curve, and we're going to just right click. So we're going to drag a surface. You see how the surface is being dragged up and down. So we're just going to bring it up a ways, so we know that it's going to be large enough to bisect the part. So we'll pick a point there. And then we're just going to grab the surface, and this, what's this, we'll call in Rhino, what's called a gumball. If you want to turn this gumball, these are just easy ways of manipulating that selected surface. You can turn that on down here where it says gumball. So with that displayed, we're just going to pick on the y-axis and just drag it up or down. You want to pick it and hold it with the left mouse button and drag it. So we're just going to move it down so it completely bisects the part. So if you see up here, we have the cross section of that surface and the part itself. So now what we're going to do is we're going to go ahead and create a section curve. We're going to go to curve, and we're going to go from objects, and we're going to go from objects, and we're going to go intersection. So we're going to select the objects that we want to intersect. So we're going to select the surface and select this solid and right click, and you'll see highlighted the cross section curve of the part itself. So that's what we want. While it's selected, it's a good idea to go ahead and use the merge command. Over here on the left, you'll see where it says join. We're going to pick join and right click. Okay. So now if we go ahead and let's hide this. Let's go ahead and create another layer here. We'll call it mask 2. Okay. So we're going to, with the surface selected, we don't need it anymore. So we're going to just right click and change the object layer to that. And then we'll turn that layer off for now. And then also, if you zoom in, you'll see that we have our curve. Okay. So we don't really need all of that. So let's go ahead and let's see, let's just hide that for a second. So here's our curve. Actually, let's explode it. We're going to pick the explode command over here, right click. Okay, so now we got access to the curve itself. We don't want some of these. We don't want that. We don't need that. So all we're looking at is a cross section from the perimeter of the cavity to the center of the part. So we're going to go ahead and just window select that, and then we're going to merge those. Okay, so now we have one curve. So let's turn our part back on. So what we're going to do is we're going to select that curve, and we're just going to move it over here. We can leave it. We'll move it to the masking surface in just a second after we rotate it. So we're going to go up here to surface.
You might want to change the color down of the masking surface, layer rather.
Yeah, we can do that. We'll change that to maybe red. Change that to red. Okay. If you turn that on, you'll see that it's red. Okay, so we're going to take the curve and we're going to revolve it around. Okay, so you can select the curve ahead of time, or you can select it during the surface creation process. So we're going to do surface, and we're going to do revolve, and we're going to select our curve that we created. Right click. So now you'll see that it's asking you the start of the revolve axis. So we want to pick the center. So with our center quadrant still selected, we're going to go ahead and pick the center point. And it's asking you for the end of the revolve axis. So we want to turn our ortho constraint on. That'll constrain the dragging to up and down or right or left. So we just want to pick another point that's in the positive Z axis. That defines the axis that we're going to rotate. And then it's asking you for the starting angle. We just want to hit enter because we're going to start at 0, and we're going to hit enter again because we're going to stop at 360. Okay, so if you look, you'll see that there's a surface that was created, and we'll go ahead and move that over to our Mask 2 surface layer. Okay, and let's go ahead and make that. You'll see that we have our surface there, but also we want to flip the normal of the surface. Here's another point too, if you create surfaces and you see that you can see through them as if they weren't there, that means you need to flip the side of the surface. A surface has a normal side and it has a back side. So if you can see through it, you're looking at the back side of the surface. So we're going to go ahead and select the surface, and we're going to type in flip. Press enter. So that flips the surface over so that you can see the surface from the direction that you're cutting. Okay, so this is our, if we look here, we can go over here now. So we got this masking surface here. Okay, so what we're going to do is we're going to go ahead and take this and hide that for now. We don't want that displayed when we're calculating our toolpath. So let's turn our geometry back on. So now you see that we have our masking surface defined. It's covering up this pocket here. It's covering all of these pockets around the boss. So that's the reason why you want to create a masking surface, so you can hide those areas. So now we can go ahead and go back into the roughing operation that we started. We're just going to double left click on it, and we're going to go into the cut parameters, and we're going to look at any parameters that we want to set differently than the default values. For the cut pattern, we're just going to use an offset, so it's going to go around and around and around, offset from the perimeter that we have selected. There's a number of options that you can select here. I'm not going to tell you what each one of them is. If you want to, I don't have the little tooltips turned on, but when you run the product, you'll probably see a little tooltip. Oh, there it is, it's turned on. So if you're interested, just move the cursor over a perimeter, it'll tell you what it means. So we've got basically a mixed cut direction, and which means the tool is going to go back and forth. You can set the start point, whether you want to start on the inside or the outside. We're starting on the inside. We've got a step over. Let's change that to 40%. Corner cleanup, we don't really need any cleanup on the corners for this roughing. We don't need an extra cleanup pass. This is all for the cavity pocket region, so this applies to the cavity itself up here, and then you can go in and set different parameters as it gets around these bosses, but we don't need any specific changes in the toolpath there. So we're going to leave all that the same. For the cut levels, we're going to go ahead and clear flats, which means that if you have any flat areas, like this lip right here is flat, this is flat, it'll put a toolpath right down on that surface. So we've got a step down. Let's go ahead and set that to 1/8 of an inch. And then we can do some step minimization, but we're not going to do that. We're going to do depth first. That's not going to apply here either. So for the engage and retract, we're just going to do a helical engagement, and then we can fit some arcs. And let's pick generate. So it's calculating where it can cut material contained within this these two perimeter curves right here. So it's only calculating inside the cavity itself. So here's the toolpath. If you want to look at each cut level, you can select the tool option, and you can select this little icon down here that says display tool levels, and it'll pop up a dialog, and you can look at each cut level in the toolpath as it works its way down. Okay. And then another good thing to do, you can double left click on the toolpath icon, and it will, if I can get it, there it is. It'll display the toolpath viewer / editor. If you're in the standard configuration or below, express or standard, you'll only see the tool motions. You won't have any of these tabs up here. If you're in the professional or higher, you have other tabs that you can do some actual editing on the toolpath at this point. But if you just want to see where the tool motions are, just start at the top and use the down arrow, and it'll locate the tool at the start point, and it'll just start going through the actual motions here if you want to do that. If you want to do it fast, you can hit the page down and it'll go really fast. So we don't really need to do any of that. We're just going to close that, and we're going to simulate the toolpath. So we'll go over to the Simulate tab. We'll turn the toolpath off, and then we'll go ahead and check our simulation preferences. We got it set to fine. That's good. Stock, let's look at the stock material. These you can set colors to the cut stock or the regular stock. Let's go ahead and change that. We'll cut the stock itself to a blue, and let's do the cut stock, say, to a lighter blue. Okay. And then you can also set the colors for edges, the silhouette edges or the sharp edges. If you want to see where the edges are on the part, we can go ahead and, for now, we can give them just a white color so we can see them, and we may turn them off. And you need to check these boxes if you want to see them on the part itself. So that's fine, and let's just go ahead and pick OK, and we'll just run the simulation. So that was pretty quick. You'll see that we have a number of step downs. If you turn the part on, you'll see that it cleared the flats on these areas right here, which is right on the part itself. Okay. And then also in the middle. Okay, so let's go ahead and move back over to the Program tab. Let's speed it up just a little bit since we're running low on time. We got the first roughing. Let's go ahead and let's skip the second roughing and go right into horizontal finishing. We're going to go 3-axis, horizontal finishing. Horizontal finishing, if you're not aware or familiar with how it works, it's going to slice your model on the XY plane at different depths in the Z axis. So we're going to go ahead and select the same perimeter. Okay, and we're going to use, I'm looking at another part over here on another screen. Let's see what we use for a tool. We used the 1/8 inch ball mill, so let's go find that. 1/8 inch ball mill. There it is. So we're going to use a ball mill for horizontal finishing, which is going to cut this on the side of the ball or around the tip or the edge of the ball in these surfaces down here. So let's go ahead and go to feet and speeds. We'll skip that. We'll skip that. Go to the cut perimeters. In a finishing operation, the in tolerance and out tolerance, you want it to be a relatively tight tolerance to get as high of the accuracy that you need. And we always have users ask us, I need tighter accuracy or I don't need tighter accuracy. The product will be as accurate as you need it to be. And you can control that with these tolerance values. You can control it with arc fitting tolerance values, and there's other things you can do to adjust the tolerance as well as and ensure that you're outputting the correct number of decimal places, et cetera, et cetera, et cetera. So the product by default will be at a certain accuracy and a certain tolerance. So we're just going to use the default tolerance of 1,000th, and for the cut levels, we're going to go, let's see, we're going to go 0.03 for the step down, and we're going to go ahead and let's see, we'll skip the optimized machining. We'll just go for entry and exit. We'll just do lines and arcs, And for advanced, we're going to put some arc motions. So we're going to set the value to 2 times the global tolerance. So our global tolerance was 1,000. We're going to set the arc fitting to 2,000. Since the arc fitting is going to be the actual last cut or the actual finished cut on the part. So if you need a tight tolerance, set it here to 1 thou and then go back over here and set that to a 1/2 thou. So we're just going to go ahead and generate that. Should be relatively quick. And if while that's working, if you're wondering what that looks like, I'll just drag my other part over here where it calculates the toolpath. Let's look at the horizontal finishing. And this one actually had optimized machining enabled, and I set an optimized step over. So if you look at the part, looks like we got it. Looks like we got it over here. Let's go ahead and turn that on. In this one, I didn't do optimized machining. So let's just look at the difference here. Optimized machining, it's going to add extra toolpaths between the cut levels so that you can get a better clearance of material in your horizontal finishing operation. So if you see here, there's no extra toolpaths in there because we didn't enable it. So there's our finishing. Let's go ahead and do that. Turn the part off. Okay. So you'll see that with the optimized machining not enabled, you have a lot of cusping. Okay. So let's see if we can just go ahead and simulate that real quick. And we'll show you what it looks like. Okay. Maybe we should not. I'm not going to get into a big simulation since it's going to drag down my system and the webinar. So we have horizontal finishing, and then we can just copy that or clone it, and we're going to do another horizontal finishing, and we're going to set that. Give me just 1 second. Let's turn that off. Horizontal finishing. Okay. The second horizontal finishing was using the same flat mill, but it looks like we had a different step downs. So let's skip the second horizontal finishing and we'll go right into the spiral machining to show you how that works. So we're going to go to 3-axis. We're going to go to spiral machining. Radial spiral. And again, we're going to contain it to this perimeter. And we're going to use the 1/8" ball mill. For the cut parameters, we're going to use a climb cut direction. We're going to start on the inside and work our way out. And for the center, by default, it actually calculates the center of your part. You can tell it where the center is. We're going to pick that, and we're going to, with the object snap on, we're going to pick a point. So that's going to be our center point. We're going to do a step over, I'll say 50 thousandths. I won't do an actual finish, surface finish, since it'll take more time to calculate. The Z depth, we already had it roughed out, so we're not going to have any additional Z depth, just one depth right on the part itself. And then for the entry and exit, we'll leave that. Let's just generate that. Okay. So on the spiral, you'll see that it started at the center because we said we want to work our way from the center outward. So the spiral starts here and it starts working its way around based on the step over, and it works its way all the way up to the last point right here. Okay, so let's go ahead and simulate that. Okay. Let's go ahead and suppress that since we don't want that to be into play. And let's run that again. Turn the toolpath off. Play. So the tool is working its way around, starting at the center, going all the way up the sidewalls. And the masking surface is doing its job. The program doesn't even know there's a pocket in here. It doesn't know there's any material behind this surface. So that's what we want. We're going to cut those out separately. So let's go ahead and there's the spiral. Let's do the radial machining. It's basically the same procedure, but you're working at a center point out. So let's go ahead and create our perimeter curve or select our containment curve. We're going to use the same tool, cut perimeters, use the same tolerance of 1/1000th. We'll do a zigzag cut pattern. We're going to set the center point again. Okay, and then for the step over, 50 thousandths, no Z containment, we'll just generate that. Okay, so here's our radial. You'll see if you can zoom in there enough. It starts at the center and runs its way out to the perimeter curve that we selected. Okay, so let's go ahead and simulate that real quick. You see that it's going up and down from the center to the perimeter. Okay, let's go ahead and pause that. We don't really need to simulate it all. If you zoom in, you'll see the surface finish. Okay, so that's basically the 3-axis, but we got more work to do because we want to program these additional pockets and these pockets up here. At this point, we don't need the masking surface anymore. So we're going to turn that off. And we're going to go ahead and let's go ahead and stop the simulation. So we're going to go ahead and we'll turn the stock off for now. So we want to machine these pocket areas. What I found works well for this particular part is to just do a pocket on the top of each one of these bosses. It works out pretty well. So let's go ahead and 2-axis. We're going to do pocketing, and we're going to do the select flat areas, and we're just going to go pick these stops all the way around. Okay, and for the tool, let's go ahead and pick we'll just use a 3/8 inch flat mill. Beads and speeds, clearance, cut parameters. As I mentioned, in 2-axis, tolerance applies to the side walls. So really the tolerance is only going to apply to these vertical walls around here. Okay, so we'll leave that set to 1,000. Oh, sorry about that. Fat fingers. $1,000. The stock is going to be 0 since we want to finish it. And we'll do an offset cut pattern. Step over 40%. Cut levels. We'll go ahead and do it on one level. So we're going to just pick at bottom because that's where our geometry that we selected. And for the entry and exit, we'll leave it to a ramp, which in this case will actually be a helical entry. And then advanced cut parameters. Okay, we can do some sorting, minimum distance. Let's generate that. So let's look at the tools. Not sure what's going on there. Looks like we got some weird stuff going on there. Let's go in here and let's fix that by, okay, let's just unselect those. Not sure why it's doing that, but let's go ahead and just pick the edge curve. And I'll just do 1 or 2 of them. I won't do all of them. You'll get the idea. Okay.
I think you had some gaps there.
Yeah.
The other one. Even in the other one. The middle one. Yeah.
Okay. So let's just do those and we'll generate that. So say this got open loops. Okay. Let's do that another way. Let's go ahead and create the curves. We're going to go ahead and we'll select our, let's go ahead and turn our masking surface on. Let's make that the default level. And we'll go ahead and do some curves from objects. And we'll do from duplicate edge tag. Let's go in here. And let's actually turn this off. Okay, right click. And then we're going to merge. Anytime that you create curves that you're going to machine with, make sure you always merge them together. So we're going to pick the join command. Okay, so you see that we have a circular curve right there. So let's go back over into our pocketing. And let's get rid of those. We'll select our curve, generate that. Okay, so basically it'll be pocketing out the top of each one of those bosses. Let's go ahead and simulate that. Slow it down. Okay, so that worked pretty well. So we just did a flat pocketing and carved out those back portions of it. So let's go ahead and see what else we could do for pocketing. To move it along, I'm just going to clone this pocketing operation. Okay, and I'm going to edit it. And I'm going to remove everything. And I'm going to select the flat area and just pick this pocket here. So we got that flat area, and let's generate that. So here is our pocketing operation for that. You can do multiple levels if you want, or you can go ahead and use a slotting operation. Let's go ahead and simulate that. See if we can speed that up a little bit more. Okay. So there's our pocket for that area. Let's see. It looks like that's everything. Oh, we wanted to do, if you have the professional configuration, you'll notice that in the simulation, we have some rough areas around these edges. You can go ahead and put a what's called a pencil trace operation through there, or you can do flat or valley machining, which will put tool paths in there as well. Let's see what we got down here. So we got a pencil trace, okay, which traced around those areas. Let's go ahead and simulate that. So it calculated all of the bitangent areas and put a tool path in those areas, okay? Or you can use the valley remachining, which gives you options to do step overs, okay? So this really comes in handy if you have edges that are not, you know, not clean. If you have a lot of odd connections and intersections going on and you need the tool to do some overlapping, you can go ahead and use the valley remachining, which works well for that as well. Okay, we got about 5 minutes. I'm just going to show you that other part, the hair dryer. Now, what's interesting about this part is that I mentioned that there's going to be a fillet around the perimeter. And if you think about this, the body or the boss of the part, this tangent angle changes all the way around. So you can't just do, you know, like a profiling around there. That won't get all of the material. And also I want to talk about these different offset values. So all of our, for our roughing operation, we just roughed the entire part. But for the parallel finishing, you'll see that we used this first perimeter curve, which is an offset. Typically, when you're doing finishing and you want to contain it, offset your perimeter curve by 1/2 the tool diameter, which is basically the tool radius, and maybe a little bit more than that, in order to contain that tool path to that area. So we're coming all the way down, and you'll see that the tool, which is a ball mill, a 1/4 inch, it's going to leave a 1/8 inch radius wherever it cuts. So that's the first approach at cutting that radius. So let's go ahead, and we did one going in the X direction, and we did one going in the Y direction. Now, one way that you can do, which works well on this, only because this is a completely flat area, is you can use horizontal finishing in order to create a path that's very similar to a pencil trace. So what we did, we selected the perimeter curve, okay? And then if you look at, let's go ahead and look at the cut parameters. All this is standard. The cut levels, we're setting the number of levels to 1, okay? Plus, we're forcing it to do a clear flats, which means that it's going to put it right on the flat surface. So if it can only make 1 level and it's got to be on the flat surface, then you know you're getting the pencil trace, the perfect bitangent tool path around the edge. And then we also have optimized machining. We don't need that. We don't need any entry and exits. We got arc fitting being enabled. Let's go ahead and cancel that. And let's just look at the tool motion without actually seeing. Let's just play. We can get it to do it. A lot of system resources being hugged up. I'm not sure why it's not going through it. So let's go this way. So basically, if you look at, let's go to this view here. Okay. So basically, what's going to happen here is going to leave your 1/8 inch fillet all around the part. And if you go, and let's go to this another area. Let's keep going around here. You'll see that the tangent changes as it goes around. So we got this bitangent here and here. So that's a trick you can use if you don't have the Pro and you want to do a pencil trace and you have a flat area. You can just use the horizontal finishing. So what else did we do here? We did the profiling. If you need to do any cleanup, we did a profiling, which is a straight profile on these flat areas. And there's another area right there. And then if you're in the Pro and you want to use the pencil trace, it works very well here as well. It'll calculate that bitangent path all the way around. Joe, do we have any questions? It looks like I made it just to the end.
Yeah, well, all the questions have been answered, so
okay.
we can open it up for questions. Anybody wants to discuss anything, just go ahead and put your question in the chat window and we'll get it in the next few minutes.
We'll just go through and look at the tool paths, roughing, finishing, spiral. Now, one thing I can point out here is that in spiral and radial, You cannot fit arcs. Arcs can only be fitted in the 3 principal planes of your part. And that's all that the CNC routers will support. For instance, if it's going along the X direction, you can put an arc. If it's going in the Y direction, you can put an arc. If you're slicing in the Z direction, you can put an arc. But radial and spiral are in neither of those planes, so you cannot fit arcs. So that's one thing that you need to be aware of. If you need a tight surface finish and you need to use spiral or radial, just make sure you adjust your tolerance value low enough to get the surface quality that you need. The same for the radial. And there's our, also I want to mention, if you want these part files and you want to practice on your own after you go back and look at the video, just drop us an email to support@mecsoft.com and we'll zip up the part package and we'll send it to you.
All right, looks like not too many questions, so we can go ahead and wrap it up, Don.
Okay.
Thank you, everybody, for attending, and we hope to see you all next month for the next edition.
Take care,
Take
guys.
care.